I've had many people ask me, what can the QC motor generator really do? What's the peak output of this device? Can I run things in my home? Will it help me get off the grid? All these are the right questions, but what I really need to do is explain to you how the technology is working. I told you before, I believe in one of my previous videos, that the coil sets, there is 12 pounds of copper. 12 coils, each one's about a pound weight each. There's 12 pounds of copper that power has to go through and be pulsed simultaneously. All 12 coils pulse exactly the same time. This is the ultimate pulse motor, and I think this is going to set the standard by which all future pulse motors are going to operate, and I'm going to explain to you why. Now here I've just borrowed from the Quanta Hybrid the axial flux generator. The two magnetic rotors here are actually the magnetic coupling for the rotoverter, but they worked out fine for this. But as you can see, on each rotor there's 4 layers of magnets, 2 layers of N52s and 2 layers of N42s. So we're talking about some serious lines of flux cutting through those coils to generate some pretty incredible power. This thing will run and run and run on very little power because the coil sets are independent circuits, and they accumulate electromagnetic energy until they reach a point of saturation, and at which point the demand for amperage plummets by a factor of 10. So if you started running this thing at let's say 1 amp in the time that it takes to load these coils up to the point where they're fully saturated with electromagnetic flux energy, then it's going to drop from 1 amp down to 100 milliamps, and it'll run at 100 milliamps and still run at the same RPM and still give you the same torque for outputting power from the axial flux generator or whatever you've got connected to this. I just did this as a test just to show some examples of the capability. Now the interesting thing about this is that I think you'll find very interesting is the powering device. Let me come over here and show you, and there it is. That little thing. 1 9-volt battery. Let's see if you get the glare off of this. 9.16 volts, and it's running the machine. Now obviously this is not under load at this time except for whatever I'm dumping in this flash cap. It's a 330 volt 450 microfarad flash cap, and it's just about 25 volts from the little 9-volt battery. But you say, well, what about the amperage? What are we doing with that? Let me just connect the camera here to the tripod. I'm pretty jumpy here. Okay, here's the amperage draw from the 9-volt battery, and it's pretty much, well, it's pretty much 0. So we're talking about microamps, and yet microamps involved from 9.14 volts over here to nearly 25 volts over here, and it will power load. Yesterday I used another one of these Duracell 9 volts, and I ran it for about an hour and fully charged these two 6-volt lead acid lantern batteries. Brought them up to full charge, which was about 6.5, 6.6 volts each. They're connected in series now because I'm going to show you how this little battery will charge those big batteries. Okay, we're connecting up now, except for the positive lead here, because I just wanted to show you what the battery voltage is of these two lead acid batteries in series. It's 12.88 volts with 12 pounds of copper having to be loaded up from that one little 9-volt battery and operate 11 pounds of rotor weight. We're talking about stainless steel, aluminum, polycarbonate, neodymium magnets, 11 pounds of mass, and 12 pounds of copper to do the work from that one little battery, and it'll power it for nearly 2 days? That's just unheard of. Well, it's because of this. Because of the amp draw. It's microamps. It reads 0. And yet, we can fully charge up some other batteries? Okay, let's do that. Make the connection. Now we're up to 1291. Drawing a little bit more than 0 amps. $12.93 at this point. So you see, the voltage is rising, charging up lead acid batteries from a tiny little 9-volt battery. The energy conversion efficiency of this is just absolutely incredible. Up to 1297 already, so it's still climbing. The stored magnetic flux that's in those coils is recycled over and over and over. And that's what keeps that amperage down to almost nothing. I mean, here we are in a full charging state, and it's not even 100 milliamps of draw. It's about 40, maybe 50 milliamps of draw from a 9-volt battery to charge 2 lead acid batteries, and now we're up to 1298. This is why I wanted to show you on a small scale, so you'd have a point of relativity to realize what it can do as it is ramped up with higher input. So that's it. I hope you get a better understanding of how this operates now, because if you're putting in more than this kind of power, then you're going to get more of this kind of action on the output side. So it's just going to scale up. But I had to show you on a small scale like this, so that again, so that you would better grasp, the efficiency of what's going on here. This power conversion efficiency is some of the highest I've ever seen, and definitely the highest that I've ever encountered on the machines that I've designed and built. And so here it is, and we want to put these in the hands of anyone who wants them. And it still can be powered by another device like another motor or rotoverter. And in the case of the rotoverter, it's not a standard motor, just like this is not a standard generator. So, for those that say, well, you can't take a motor and run a generator, you're just going to get losses. Of course you would, if that was a standard motor and it was a standard generator, but these aren't. And you can see now why they're not. Thank you. Oh, also I forgot to mention that some would think that these caps are pretty much running it, but actually they're not even connected, velcroed on. They were just part of the Quanta Hybrid on other experiments. I just left them on so you didn't have to see the velcro on them. A piece of white plastic. That's it. And because the rest of it is quite simple, what it's doing, how it's doing it, and so effective.